Well, hello and welcome back to math class. As you can see, we're going to do a video today for our lesson, which is 8.7, Writing and Graphing Inequalities. This is in your book on page 383. Let's make sure this up here on the bottom of the screen. Page 383 if you want to follow along. Otherwise, you can just watch here on the screen. Some of you might have noticed how this copied off kind of funny. I'm not sure why that happened. So, all right, well, let's go ahead and look at some statements that are talking about inequalities, and then I'll explain a little bit. So our first statement here, we have a watch, and it says class starts more than 3 minutes late. So if I wanted to kind of show some solutions on a number line, I know that I have the number 3, so I probably would put a 3 on here. And I like to go ahead and put at least 5 numbers or tick marks on my number line. All right, so class starts more than 3 minutes. Does that mean it can start exactly at 3? No, there's a phrase where it says more. So some answers could be 4. 4 is more. 5. I couldn't do any of these because those are all less than. Okay, so I could keep actually going this way if I had more room on my number line. Let's go down to this next one. This one says you need at least, oh, here's another thing, at least 3 peaches. All right, let's make another number line. At least, let's put the 3 down here this time. 3 meaning I can have 3. Could I have less than 3? If I need at least 3, could I have 2? No, at least 3 means I have to have that many at least. That's the least amount I could have. So 1, 2, 3, 4. All right, I have 5 numbers here. So at least 3. Would 4 be at least 3? You need at least 3 peaches. Could I have 5? Yeah. Anything over 3, because it says I need at least 3. 3 would be the least amount, but I could have more. This one says the temperature is at most 3 degrees Celsius. Oh, here's another one with the number 3. So here's my 3. The temperature is at most 3 degrees Celsius. Okay, so could it be 3? It's at most. So it could be 3. Could it be 4? It's at no, because that would be over, and it says it's at most 3. That's the highest it is. So this one would be all the ones that are less than. All right, let's look down here on the next one. After playing a video game for 5 minutes, you have fewer than 3 points. All right, so they kind of try to trick us with an extra number here. This is extra information, 5 minutes. You have fewer than 3. So I'm going to have a 3. If I have fewer than 3 points, I can't have 3. And I can't have 4. So that means I could have a 2. I could have 1. I could even have 0. These are going to be what we're going to call inequalities, because as you can see, there's more than one answer available for these problems. So what I'd like for you to do is on your piece of paper, let's talk about what an inequality is. If you would go ahead and write in your notebook, inequality symbols. Write those words, and we're going to look at what the inequality symbols are. You're going to be, actually, you probably already know all of them. The first symbol we're going to put in our notes is this one here. Okay. This is the less than symbol. So what does this one mean? This means is less than. Another thing you could say, instead of saying is less than, you could say is fewer than. That's another word. Okay, so this symbol here means it's less than or fewer than. Okay, the next symbol, obviously, I'm going to skip space here, it would go the other direction. And some of you already know it is greater than. So we're going to say greater than. Another way we could say it is more than. So we'll have these words available to us today. Now, the new symbol I'm going to show you is one we've actually talked about in class, but we haven't really done anything in our textbook. And it's a symbol that looks like this. It's the less than symbol with a line under, so it's a little bit different. This symbol says that your answer is less than, and when I add that little line, that means it could also be or equal to. Some people say that you could also say this, and you're going to see it in our story today, is at most. And I'll show you some examples of that. But keep these words next to this symbol, is at most. And the other phrase I would like for you to put with this one is no more than. These phrases are going to help us later when we get ready to write inequalities and graph them on a line. All right, hopefully I've allowed some of you to catch up a little bit. The next and the last symbol is going to go the opposite direction, obviously, with that equal to line. And this is greater than or equal to. Now, I know some of you write a little bit slower than I do, and if you do, that's where you're going to pause the video so that you can make sure you have these phrases in front of you. The other phrase that this could be is, instead of at most, it would be at least. And the last one, if this one is no more than, this one's going to be is no less than. All right, so make sure that you have these phrases handy for us to look at when we're ready to start solving some of these problems. All right, so I wrote this problem on a separate sheet of paper just so we can look at this screen again. You can go ahead and turn to a new page so that you can continue writing down our samples. So the first sample we're going to do is, it says a number C is less than -4. Now, if I look here on the notes that we just took, there it is, less than. So there's the phrase right there, is less than. So if I wanted to write this as an inequality, I would break this into parts. Here's the first part, a number C. Well, I think I know what that is. That would be this, a number C. Is less than, well, according to my notes up here, is less than goes like this. And the last thing is -4. So here would be my inequality. Okay, let's try another one. All right, so there we go. I got that on there now. The next phrase I have is a number K plus 5 is greater than or equal to 8. Well, here's the phrase that we saw in here, is greater than or equal to. There's the phrase right there. So let's do this. Is greater than or equal to. All right, well, I know that that symbol is this right here, according to my notes, greater than or equal to. All right, so a number K plus 5. A number K plus 5 is greater than or equal to, and the number is 8. And so my inequality is written like this. All right, so here's my phrase. 4 times a number Q is at most 16. All right, what I'd like for you to do is I'd like for you to see if you can write the inequality. Look here at our phrases and see if you can find the one that matches with what's in our sentence. You've got these in front of you. The phrase is 4 times the number q is at most 16. Hopefully you found that phrase right here. Is at most. Is at most goes with this symbol. All right, now let's see if we can finish writing it. 4 times a number q. 4 times a number q. Well, that would be like this. 4 times a number q is at most 16. Now, some of us already know that 4 times q could also be written like this, touching. And so this could be our final inequality. All right, so this is how we write inequalities. We look at the statement, we find the phrases that match with our inequality symbol, and then we go ahead and add our variable and then our numbers. All right, well, let's continue on with something else dealing with inequalities. All right, so we're going to check inequalities now. If you would go ahead and write this one down in your notes. The inequality says x plus 1 is greater than 7. That's the inequality. Well, what if I would tell you, the semicolon there, I would like for x to equal 8. I want to know if this would be a solution. Okay, so write this all down. We're going to substitute the number 8 in for x. So everybody needs to write in here, 8 plus 1 is greater than 7. Yes, we have to write the steps. I know. A lot of writing here, right? 8 plus 1 is 9. 9 is greater than 7. Is this true? Is 9 greater than 7? Yes. So this is a solution. Okay? This is a solution. It works. Let's try another one. What if I would have you write in your notes 7y, 7 times y, is less than 27. That's my inequality. It has the inequality symbol. I would like to know if this number 4 would be a solution for my inequality. Well, let's substitute 4 in for y. So I'm going to put the 7. Instead of putting the y, I'm going to put times 4 is less than 27. All right, what's 7 times 4? 7 times 4 is 28. Copy the rest. Is 28 less than 27? Nope, this one is not a solution. So sometimes you'll see people do something like this. They'll just kind of cross it out like this. Some people will write not a solution. So we found out that the number 4 does not make this inequality true. All right, I'm going to give you one, and I want to see if you can figure out if this is a solution. In your notes, would you go ahead and write 5 is greater than or equal to z divided by 3, right? That's how we write that. I would like to see if, for the letter z, if 15 would be a solution. So go ahead and rewrite it, substituting in. All right, so let's see, I would write 5 is greater than or equal to, we're going to substitute z out and put 15 divided by 3. All right, so let's see, 5 is greater than or equal to, 15 divided by 3 is 5. Is 5 greater than or equal to 5? Yeah, 5 and 5 are equal. So this is a solution. All right, so we have, we wrote some inequalities using the inequality symbol. We figured out how to write them. We then also figured out how to check for solutions to see if substituting in a number would make the inequality true or not true. And the final thing we're going to do today is we are going to graph an inequality. Final thing. So let's go ahead and write in here, graphing an inequality. The first inequality I'm going to have you graph is this one. A is less than 4. Now, obviously, if I asked you to give me some solutions, you'd give me 3, 2, 1, 0, -1, -2. You would be able to give me some solutions. There's lots of solutions. There's not just one. And because there's lots of solutions, we graph that. So I'm going to have you go ahead and let's go ahead. And I like to put at least 5 tick marks on my number line. 1, 2, 3, 4, 5. I'm going to put the 4 in the middle. So this would be 5 and 6, 3 and 2. In order to graph this inequality, I find the number that's listed here. It's the number 4. I put a circle here first so I know where I'm at. Now, does this say that A is equal to 4? No, it doesn't have the equals line, so it cannot be colored in. It says that A is less than. So if I'm going to go less than, that means I'm going to take my pencil and I'm going to color all of these numbers less than. All of these are solutions. 3 is a solution. 3 is less than 4. 2, I could even say 3.5 is less than 4. All of this is colored in because all of those numbers would be solutions. Okay, let's try graphing another one. What if I said, let's do J is less than or equal to 7? If I was asked to graph it, I would make a number line. I would put 5 tick marks. I would go ahead and put this number in the middle. This would be 8 and 9, 6 and 5. All right, the first step I do is I find the number. It's right here. Put an open circle. Now I look. Is this say it's equal to? It's less than or equal. Oh, this has the equal to sign, whereas this one up here did not. Because this has an equal to sign, it means 7 could be one of my answers. 7 is equal to 7. Now we're going to color. Let's see which direction. It says J is less than or equal to 7. Less than would mean I'm going smaller. So once again, I would color my number line like this. All right, let's go ahead and try 2 more. Let's do N is greater than 0. Some of you already are figuring out how to do this. Make our number line. 5 tick marks. The number I have is 0. I'm going to put it in the middle. Now we have to number our tick marks. Let's see, this would be 1 and 2, -1, and -2. Put an open circle here at 0. It's not equal to, so I cannot color it in, but it does say N is greater than 0. Greater means numbers that are larger than 0, so that means all of these would be solutions. 1 is larger than 0, 2, 3, 4, even half. All right, like I said, we're going to grab 2 more, so this is our last one. Last one's going to be, I'm going to kind of trick you on this one. -3 is less than or equal to P. Okay, let's see. Make my number line. 1, 2, 3, 4, 5 tick marks. -3. Do you remember how to number lines? This would be -2, -1. Look at your name tag if you forgot. Remember, these numbers are going closer and closer to 0, and these are going farther and farther away. I'm going to add an extra tick mark just so we can see where 0 is. Oh, let's look at this inequality. This one's written differently than the other 3 we've done. If you notice, the variable was always first. The variable is not first on this one. The variable is listed second. So in order to not get myself confused, I like to take this and flip it, which means I like to put the variable first, the integer last. But that means I have to make sure I have my inequality pointing the right direction. If you notice, the inequality is pointing to the -3. So I still have to have it point to the -3. So I basically took this and flipped it around, so now it's easier for me to read. This is still saying -3 is less than or equal to P. I can read it backwards. P is greater than or equal to -3, which is what I wrote over here. All right, so now let's see. Find the -3, open circle. It has the equal to line, and because it has the equal to line, that means my solution could be equal to -3. P is greater than or equal to -3. Greater than, that would be this way. And so I'm going to color this direction, meaning my solutions would all be greater. Okay, so this is all we're going to do with inequalities today. We will do a little bit more of inequalities tomorrow. All right, you may go ahead and get your math books if you don't have them already, and the teachers will let you know what your assignment is going to be.